What's up, everybody? My name's Kat. Welcome back to another weekend vlog. And in this one, I'm going to get a little bit deeper than I did in the last one, since I didn't really dive deep in the last one. Anyway, today I was going to talk about something that just fascinates the holy crap out of me, and that's like outer space and the galaxy around me. So here's a thought process here. You go outside during the day and you look up at the sky, and what do you see? I mean, not counting clouds, birds, planes, blimps, mushroom clouds, whatever it is you see when you go outside wherever you live. You see a blue sky. Go out at night, when you see blue sky's gone. This is like elementary school science here. You go outside during the day, you look up, you see a blue sky because the light from the sun refracting off the moisture in the water in the atmosphere, and the color spectrum refracts blue, and that's why you see blue. I mean, that's pretty much the basics of it there. But when you go out there and you look up, you physically see the sky. It's called the sky. I mean, we have a name for it. You look up there and you can see it. It's there. But it's not there. You're looking up at something, there's nothing there. I mean, you think about it. Think about it real hard what's actually up there. There's air, oxygen, helium, nitrogen, and hydrogen, and probably a couple other chemical elements, and then various different levels of pressure between here and there. But from the ground level to outer space, there's nothing there. I mean, there is physically, if you were Superman and you walked outside and you flew straight up, the only thing keeping you from coming back down is gravity. Once you break that, there's nothing there. It's not like you're going to go ding and hit the top of the atmosphere and all of a sudden you're going to bounce off, or you have to trudge through layers of crap to get. There's nothing to physically touch between here and there. Now take that thought and go outside at night and you look up and you see stars, you see the moon, and you see planets if you know where you're looking, whatever. So you're not looking at the night sky, as everybody calls it. You're not looking at the night sky. When you look up at night, you're staring at outer space. You are staring into the universe. Now think about that for a second. You're not looking at the night sky as what we see through Earth. You are actually looking into the universe. Most people, you think of it as, okay, so here's the ground you stand on. You want to do it like this or whatever. So here's the ground you stand on. Here's the sky above you. Everything that happens goes in this nice little arc right here. All the moon, stars, the planet, the sun, everything you see happens right up here. And so when you look up, you see everything here. I mean, when you look up at the sky, you can see from horizon to horizon all the crap that's there and everything in between. Everything goes in an arc. You can see it, but it's not there. It's more like you're standing here on this flat surface looking up indefinitely in every direction. You're seeing as far as humanly possible. That just really blew my mind the first time I really thought about that, because I'm like, everybody goes outside and you look up like if we're in a snow globe and there's this perfect little dome over us and everything you see is right above you to where it's right there, but it's not there. There's nothing there. It's a window made of nothing. It's a window of air into the universe. And so, I mean, if you think about that, you're basically standing in space in an essence there, because if you got the earth, obviously the ground on the earth is round, but if you think it was just the flat part that you're looking at, in every direction you look is just air. That's all that's there. And what's really cool about that is everything that you look at out there is from the past. Now let me explain that a little bit more into the way light actually travels and stuff. The closest star, the closest visible star to planet Earth is Proxima Centauri. It's about 4.2 light years away. Now, what that means, when you go out at night and you look up at the one white dot in the sky that is Proxima Centauri and you stare at that star, you see the little twinkle, a little flicker of light. What you're seeing there, that light that you're staring at, is from 4.2 years ago. You're not looking at that star as it is right that second. You're looking at what it was in the past, and that's the closest star to us. I don't know the farthest one there because we haven't found them all. We found, I don't know, some odd billion stars in the galaxy that we can actually see, and that's just the ones we know of, the visible stars that we can see that the light has actually made it to us or whatever. So if there's a star that's, let's say, 5,000 light years away, that's a long ways away. But when you stare at that white dot in the sky from 5,000 light years away, you were looking at light that left that little beacon of gas and fusion and everything else 5,000 years ago. You were staring at something 5,000 years in the past. Think about, I mean, as far as like the history of the Earth goes, 5,000 years is not that long. But as far as like generations go, think about how many generations of people back that was long time ago, and how much the world was different when the light left that one little star there before it even got here. And that's just. But a little bit of closer scale here. Okay, our sun, you've seen it. I'm pretty sure it's a big orange thing at night, or a big orange thing during the day. It's kind of hot, lights of the earth. You probably know of it. It takes light from our sun about 8 minutes to get to us. And you know how close the sun is. You can see it. It's, we've all done the little diorama, or at least seen them, of our little solar system here. We got the big sun in the middle, and the Earth is, it's pretty close. Hold on, better get the full egg shape for the science nerds out there. The Earth is pretty close to it, and it still takes the sunlight that you're staring at 8 minutes to get there. So if you stupidly stare at the sun, you're not staring at the sun. You're staring at the sun 8 minutes ago. Now, you look at Jupiter. Now, if you follow me on Twitter, if you've seen me talk about it before, it's like I love looking at Jupiter. That's one of my favorite planets. Jupiter and Saturn, they're so pretty through a telescope. And this is something that didn't really occur to me until I got really into astronomy. When I'm out there with my telescope and I'm looking up and I got it focused in on Jupiter and I'm looking at the beautiful rings and counting the moons and stuff around it there, it takes light from Jupiter to Earth 32 minutes to get there. That's not something I ever thought of when I was really doing this sort of thing of like, I always pictured you get a telescope and you're looking at something. You are physically seeing it. It's amplifying your vision to see that. That's always how I thought it, is it going that way. In reality, it's coming this way. The light from it, the bigger the telescope, the wider this is, the more light it can let in, and so the better the picture you can see, the better the clarity, color, and all that other stuff. But it's coming this way. You're looking at light from Jupiter 32 minutes ago. And that was just like, again, that blew my friggin' mind hole. The further planets are further away and stuff like that. That is just, I don't know, that's just really cool and just kind of trips me out. Whoa. I mean, the universe itself is so cool. And the grandiose scale of everything. That's something else that really baffles me. Because on Earth, we got units of measurement we can all... if somebody's like, oh, okay, well, they made some new battleship. That thing is 3,000 tons. I'm like, 3,000 tons? That is, holy crap, that is ridiculous. But you're like, got this big thing, there's steel, water displacement, lots of weight. I can see that. They say the density of a neutron star, if for somehow a reason you condensed it into a thimble, one tiny little thimble, if you condense the entire size of a neutron star down to that much, the density of that would go through the Earth. I mean, think about that. That's just, I'm like, how is that even possible? Something this thin, tiny little amount is so dense, which means the atoms and the molecules are so close together that it has so much weight that it would just pass right through the Earth. It's immeasurable as far as distance. And you look at our sun. I mean, it is big. It's like 1,000 times bigger than the Earth. We've got this one little pixel here is Earth. Here's our sun. It's huge. I mean, you realize how big that is. There are stars out there that we've recently found that make our sun look like that little bitty pixel right there. That little bitty pixel right there is our sun. And here's a planet. I mean, here's a star. And that's ones we've seen. I mean, like, that is gargantuan to the point where it's like comically big. I don't know, that just kind of like trips me out to think about the scale of stuff on there. And they get into supernovas and they start talking about how many billion tons of debris is shot out at the speed of light in all directions when the supernova goes. I'm like, okay, so you get into the units of measurement that far, and you got to start using new words like Planck to figure out how far something is. And AUs, the astronomical units, is how distance between Earth and the sun and the stuff like that. Because miles no longer work. I mean, you look at the speed of light. 1 light year is roughly about 6 trillion miles away. Or maybe even a little bit further, like 6.5 trillion miles away. That's a long ways away. Anyway, I'm kind of done rambling here or anything, but I just kind of wanted to dive deeper into this with you guys. When you think, I mean, how many of you guys actually know that? I'm sure a lot of you are intelligent individuals, but how many of you have really even thought about that? You're just outside at night and you look up through a window of nothing into an open universe that you're staring into the past. It's kind of cool. Anyway, thank you guys for all the support on these. Hope you guys enjoyed it. You have a good one, and I will talk to you later.